So, very good morning, all of you. Today's topic is the introduction to data science. And by the way, I'm Dr. K. Santhi Sree. Without any delay, we'll start with the discussion with what is data science. As we all know that we have a lot of data collected in the real world, huge amounts of data is getting accumulated every day. Kilobytes of data, then came megabytes of data, and then came petabytes of data, terabytes of data, exabytes of data, zettabytes of data, yottabytes of data. There is a lot of data which is getting accumulated. There are multiple resources where you collect the data, maybe from Instagram or from the Facebook or from the Twitter, or we can say relational databases, maybe a student database or a hospital database or an election database. Everywhere the world is with lot of data. The very important point is we collect huge amounts of data, but processing it simultaneously is very important. The point we need to remember is the more the data we receive, the faster should be the execution. The faster should be the execution. Otherwise, a lot of data getting accumulated. For example, let me define what is data initially. Before I go into definition of a data science, let me explain initially what data is. As we all know, or I can simply say data is a raw thing, a raw process. Again, a question mark on your face. What exactly data is? Let me take a small illustration. I'll consider 35 a number on the board, just a value 35. When I just take a value 35 here, what is your answer? What is your answer? When I take a value 35, I can say it is just 35 kilometers I traveled, or I can say 35 is the price of an item I purchased today in the supermarket, or 35 can be age of a person, 35 can be the marks what I have secured. So when I say marks is equal to 35, then I can say now a specific meaning is given. I have given some sense. Some you can say data has some sense. Some definition is given. When I simply left a number 35, which is just a raw thing, has no complete meaning at all. But when I say marks is equal to 35, it makes some sense. Okay, marks is 35. Now, how can I analyze the data? How can I bring a decision making out of it? Now I can write a line if marks is equal to less than 35 or less than or equal to 35. I can simply say I am on the fail category. If the marks I secured is greater than 35, then I fall into the category of a pass. So I'm bringing some conclusion out of it. I'm drawing some observations out of it. I'm analyzing some data. I'm bringing some decision making. If marks is less than 35, I'm under pass fail category. If the marks is greater than 35, I'm under pass category. So whenever you collect a huge amount of data from the real world, it is very important to analyze your data. It's very important to make a decision making out of it. A visualization of the data is very important for better understanding of the data. Quickly moving on to the next slide, you can see that there are various types of data existing in the real world. One is a structured data, the other one is a semi-structured data, and third one is an unstructured data. So you have three types of data existing in the real world. One is a structured data, other one is a semi-structured data, and third one is an unstructured data. I can give a simple example out of it. You all know that all the relational database management system, all the data is stored in the form of tables. What is a table? It is a collection of rows and columns. Every row is again a collection of multiple attributes. So we can just define a relational database as collection of tables. Every table is now a collection of rows and columns, and every row is again a collection of multiple attributes. We can just call it as a row, or we can call it as a tuple. A multiple means for a row, right? So any data that is stored in the form of a table, we call it as a structured data. You can see this example here. You can see there will be multiple operations which are being performed, like storing of the data, updating of the data, retrieval of data from a database. So how do you define a database management system? A database is nothing but a collection of data, a collection of tables. Now, what do you mean by management system? The various operations you perform on the data is what is called the management system. Addition of the data, deletion of the data, updating of the data, retrieval of the data, joining the data, altering the data. These are the various operations what we perform on the database. The complete thing, what we call it as a database management system. To say it otherwise, the various operations that we perform on the data is what is called the database management system. So any data that is stored systematically or in an organized manner in the form of a tables, we call it as a structured data. So RDBMS is a good example for a structured data. You could see the slide here, SQL database. That's a good example for a structured data, because how do you retrieve the data? By using a structured query language, right? What is an unstructured data? The name itself says unstructured, no predefined structure. It says no predefined structure, no data model. Let me give you a simple example. You can see when you just look at an YouTube or an Instagram or a Google or a WhatsApp, so you can see a lot of data has been shared among us, maybe in the form of a text, maybe in the form of a video, or maybe in the form of an audio or a PPT, or it can be a PDF, or it can be text message. You store your data in the multiple ways. You store your data in the multiple ways. When you have this combination of data, this is what we call an unstructured data. What we call it as an unstructured data. I'll give a simple example. When you go to a Google search bar and type a statement like search for information retrieval systems. Now Google search engine is going to download all different types of data for you. Maybe a set of PDFs, maybe a set of PPTs, maybe a set of videos, or maybe a set of audios. It can be Excel sheets. So no information retrieval system is 100% perfect. Right, so it retrieves different types of data in the different formats. Nowadays, everybody is so busy on the Instagram or on the WhatsApp. Soon after you get up from your bed, you just share your photo saying good morning. You drink a cup of tea, you share a photo to your friends. And then you start going to the office, you share a photo. Everything has now become a fashion, right? Whatever step you take, a second by second or minute by minute, everything is posted on the WhatsApp. I feel personally like all the data which is shared on the social media, especially WhatsApp or Instagram or what it is, a YouTube. I think 80% of the data is just as very user-friendly data. I feel where we are not collecting any information. Maybe 20% of that is purely technical data. It contains only technical information or some sort of knowledge to be shared to your friends. Right, so I think nowadays the students are very busy on the WhatsApp. Everybody can live without a heart, but nowadays the people cannot live without a mobile beside them. Is it true or not? Everybody is addicted to the mobile. Everybody is so busy on the social media. You post second by second whatever you do on it, right? So we have different kinds of data in the different formats. The collection of it is what we call an unstructured data. Is what we call an unstructured data. Now coming to the point, like I just gave a definition. What do you mean by a data? What do you mean by a data, right? I just said that data is a raw thing. So out of the data, you generate an information. Out of that the information, you generate some knowledge, you generate some patterns, you make some decision making. You analyze your data, you visualize your data, right? Without just lagging anything more, let's just look at the present slide, which shows what is a life cycle of a data science. Which shows the life cycle of a data science. Now, what is a data science? Before I go and talk about the architecture of the life cycle of a data science, you all know that any task you do. Let me give a simple illustration. You start a construction of a house. What generally you do? You go and approach an architect, get a good plan, a superb plan or exclusive plan. Out of that, then you start collecting all the permissions from the maybe from the government or from the municipality, and then once the permissions are granted, then you'll go collection of the material like a sand, cement, water, iron, steel, bricks, and so on, right? Once all the material is being collected, and then you'll look at the you'll just the status of the soil, and then you'll start the weather ambience, and then start the construction of the building. So you go in a certain procedure. So you can't straight away go and start construction of building at this particular moment of time. There is a set of instructions or a set of rules or a set of protocols or a set of steps or a procedure need to be followed. Get the permission from the architect, get the plan, then collect the information or the material, and then you start collect the labor, and then you start the construction or execution of the building. Just like that, any task you do. Let me give another example. You all are familiar with the post jobs on the software. Everybody wish to have a good job in the high-tech city or in the software field, right? So any task you do, you can't straight away go and just start the task, right? You have to understand what the task is. Then what are the input requirements to that task? What is the procedure to be done, and what is output that I have to generate? What is the output I received? What decisions or should I make out of it? How do I visualize the data? How do I analyze the data? What is the analysis I got out of the data? That is very important. So any task you see in the real world, you can't just start like that. So there are certain steps to be followed, right? Just looking at the architecture of a data science, there have been multiple steps. There have been multiple steps. There have been multiple steps. First one is data collection. The first one is data collection. Just now I said to you, whenever you want to do any task, maybe execution of a project or a construction of a building or voting for an election or whatever task it is, we first need to collect the data. So collection of the data is very, very, very important. Collection of the data is very, very, very important. This is the first step we need to identify in the data science life cycle, or a data architecture of a data science is data gathering, data collection, data organizing is very important. So you need to collect the data. And the second step you're going to do is data cleansing. What do you mean by cleansing? Cleaning of the data. So you have a lot of data which is existing in the real world. Every data in the real world is very important. Not even a single bit of data is to be wasted. It's not, you cannot say the data is useless. Every data is useful. All you need to do is you need to collect the data depending on the task you do. Every bit of data is very important. You choose the right attributes. You choose the right data depending on what task you're doing. So I once again repeat, no data in the real world is useless. Every bit of data is useful. You're going to choose the data which is so useful for you, a set of attributes so useful for you. From that database, what you gathered, or from that data, what you collected from the real world. From that real world. Then now, what do you mean by data cleansing? Data cleansing is nothing but cleaning of the data. So when you welcome the data, huge amounts of data, petabytes of data or zettabytes of data or yottabytes of data, you can't just blindly store or upload the data into the database. You can't do that. You have to clean the data. You have to pre-process the data. You have to cleanse the data, remove the inconsistent data, remove the noisy data, remove the noisy data. So very important is that, very important is. So the first step in the life cycle of a data science is the data gathering, data collection, data organization. The second step is pre-processing of the data. The second step is pre-processing of the data. The third step, what we are going to do is, we do what is called, once the data is collected, we are going to apply a lot of machine learning algorithms. We are going to apply a lot of models on the data collected. There have been a lot of algorithms or models available in the real world. So once the data is collected, once the data is cleansed, we are going to apply the algorithms on the data. Once we apply the algorithms on the data, we are going to categorize the data. We are going to cluster the data. We are going to gather the data. We are going to cleanse the data, and then we are going to apply multiple models on the data, and then we are going to segregate or categorize the data into multiple groups. Once we apply the models, the fourth step we are going to do is a coding of the data. There have been multiple languages, or there have been multiple which have been available in the real world, maybe like starting with the C and then Java, and then you have R, then you have Python, you have Perl, a lot of scripting languages as well. You can just code your language, you can just code your work in algorithms in multiple languages available, multiple applications available. Once the data is coded, now you are going to generate some output out of it. You're going to generate some output, you're going to generate some patterns out of it. And then you're going to make some decision making. So making decisions on the data is very, very, very important. And then finally, you're going to analyze the data, and then you're going to visualize the data. So the life cycle of a data science contains multiple steps, like one is the data gathering, data collection, data pre-processing, and then applying a multiple machine learning algorithms on the data, and then code the data, and then analyze the data. The last step is visualization of the data. Now I talked about the third step, that is what are the various machine learning algorithms. Once you just look at the slide, you could see there are supervised algorithms on the left. Middle one is unsupervised algorithms, and third one is reinforcement algorithm. There is a spelling mistake in this. It's not reinforcement algorithms, it is reinforcement, R-E-I-N, reinforcement algorithms. When you just look at that, supervised algorithms, regressions, decision tree classification, random forest is a classification technique. KNN stands for k-nearest neighbor. And then with logistic regressions, Navy Bayes classification, and SVM stands for support vector missions. All the algorithms which are mentioned here, which purely comes under supervised algorithms. So KN is where K stands for number of clusters. So all the algorithms which are mentioned here comes under classification techniques. The second category is unsupervised algorithms. I can say clustering is a good example for unsupervised algorithms. PCA, principal component analysis. K means is a clustering technique. Right? Association algorithms. A priori algorithm comes under clustering. FP growth, frequent pattern growth, comes under clustering. Hidden Markov model also comes under clustering. So these are the set of algorithms which falls under unsupervised algorithms. When someone asks you what makes the difference between a supervised and unsupervised, supervised also can be called as classification algorithms. Unsupervised can also be called as clustering algorithms. Another difference is classification will always hold a class label or pre-defined data or pre-trained data. Unsupervised algorithms has no predefined data or no pre-trained data. This line is very important. You need to understand what is meant by predefined data or a pre-trained data. Right? So the only difference between classification and clustering techniques is classification always holds a predefined data, pre-classified data. Using that predefined data, we are going to categorize or we are going to identify to which cluster or to which database or to which group does the new sample belongs to. So by using a predefined data, I can identify to which cluster or to which group does the new sample belongs to. Unsupervised algorithms, that is clustering, comes under unsupervised algorithms. So K-means is a good example for a clustering. So these all doesn't have, this clustering algorithms do not have predefined data. No pre-trained data. Every sample you come across is always a new sample. You are going to cluster them or categorize them into multiple groups based on some characteristics. Maybe a distance, maybe a diameter, maybe based on the color, or maybe based on the size. You are going to cluster into multiple groups. The other third category is what is called semi-supervised algorithms. We also call it as reinforcement algorithms. I'll give a simple example. I applied for a loan. So I paid all my EMIs very correctly. So my loan is cleared. So I have a good score at the bank. Oh, mom has taken a loan. She has paid all her EMIs regularly every month. So my CIBIL score based on the credit card or is very good. So I have given a good rank in that. I have paid it in a very correct manner. So next time when I try to apply for a new loan, they'll check my feedback. They'll check out my feedback. Yes, there is a good track record of paying the EMI, so new loan can be issued to the so and so person. So reinforcement algorithms mainly depends on what is called the feedback. Mainly depends on what is called the feedback. You have different types of algorithms as I mentioned right now. They are supervised algorithms, unsupervised algorithms, and reinforcement algorithms. Let's talk about this in depth when we discuss about each and every topic based on your syllabus in the next coming up units. For right now, it's just an introduction of what data science is all about.